Uh, so in the last lecture, we have a discussion on filter. So in the filter, we discuss what is mean by filter. There are two types of the filter. One is analog filter, another one is digital filter. In simple definition of filter, we discuss that in signal processing, whatever the signal we don't want at output, so that signal need to be removed from the original signal. So that is the basic function of filter. So in case of analog, we have a low pass, high pass, band reject. All these are the types of analog filters. In digital filter, there are two types of the filter. One is finite impulse response, another one is infinite impulse response. Now, when we look toward the designing of filters, there are different methods of designing a filter. In both the categories, the filter designing is a very important aspects when you want to design a filter as per the customer need. So we have a different method in related to the IIR filter. First method of designing IIR filter in digital domain is approximation of derivative. Second method is your impulse invariation method. Third one is a bilinear transformation. I think we discussed the problem of approximation of derivative, impulse invariation, and bilinear transformation in digital domain. In parallel aspects, we have a discussion on the magnitude response of analog filter, Butterworth filter. So here we discuss how to find out the coefficient of filter. So capital N is equal to that formula we discuss, and according to that we have a discussion on how to find out the coefficient of the filter when the four parameter is given, that is passband filter, passband frequency, stop band frequency, passband attenuation, and stop band attenuation. And after that, one point is that in by using the simple bilinear transformation when h of s is given, and how to find out the by using that h of s, we are going to convert into h of z. So that h of z, when we find out the h of z, so in h of z what happened, there are different methods to design the h of z. So by using that method, we understood that how to design a filter or convert h of s domain into h of z, and this is nothing but the designing of filter. So this is one part of the discussion. Now we have given the h of s domain, we are converting this into h of z, and these are the three methods of discussing. So s is get converted into the z domain. So these are the point we discuss. I hope you understood the discussion, or if you have any problem, so definitely we have a this discussion on these points. So see, my screen is visible to all. Screen is visible to all. This is the magnitude response of the filter, low pass and high pass. These are the see, this is the pass band portion, this is stop band portion, this is ideal filter. Dotted line shows the ideal filter response. So this dotted line shows the ideal filter response here. This is for the low pass. So this is for low pass and this is for high pass. So high pass is opposite to the low pass. What where we are going to pass that, instead of this we are going to stop that frequencies and allow all the frequencies which we want to pass. So this is the what you say that the response magnitude response diagram of low pass and high pass filter. My voice is clear to everyone? Screen is visible? Screen is visible?
Yes, sir.
So this is again a diagram which is available in analog domain and it is in the digital domain. So if you see here the parameter which is given 1 by 1 minus 1 plus lambda square, 1 by 1 plus epsilon square. Lambda and epsilon is a this attenuation in pass band, attenuation in stop band. So this lambda representing attenuation in stop band and this represent attenuation in the pass band. So these are the points we discussed in the last discussion. So pass band allowable attenuation, stop band allowable attenuation. So these are the four parameters. Depending upon this, we discuss these expressions. From that we find out the s values. So when we have a odd value and when we have a even value, so we find out the values of the s1 and s2 and put on the circle. So if you look toward the circle, so circle value is given here and it is opposite value. So zero point 0.5 minus j, it is like a omega which we learn in a dft. So mirror image of the values is there. This is the formula for n is equal to n is greater than equal to log of under root 10 raised to zero point 0.1 alpha s minus 1, 10 raised to zero point 0.1 alpha p minus 1 and log of stop band frequency divided by pass band frequency. So this formula you can use for the find out the value of coefficient of the filter. This n represent the coefficient of filter. Now why we are interested to find out the coefficient of the filter? Because once you know the coefficient of the filter, you are able to find out this diagram. That means which is we seen, that is when n is there, so whatever the value is n, depending upon that response is given. So that's why we are trying to find out the formula of the filter. This माइक नहीं. So these are the steps to design analog Butterworth low pass filter. So I hope you understood the discussion. Some of the people are solved the problem. They send me the WhatsApp also. So from the given specification, find the order of filter, round off to the next higher value, find the transfer function h of s for a cutoff frequency is equal to 1 radian per second. Why we are finding this value for cutoff frequency? This is the normalization of the filter. So always we are trying to find out the value of n for the cutoff filter. Then once you find out the value of cutoff filter, then calculate the cutoff frequency from the given parameters and substitute the h of s domain in s is equal to cutoff frequency. Then it is actual designing of Butterworth filter. Once you are able to design a filter, then the next step is to convert the filter as per the what you say the methods. If someone asks you to design a filter for using the bilinear transformation, then you can use the formula for s is equal to conversion formula you can use and convert this filter into the z domain. If in problem statement it is asked use the approximation method or bilinear method, then you use it. So these are the things. So if I summarize all these discussions, so try to understand So just see the discussion, because now this is the filter. Now, when we want to design a filter, so there are two methods to design a filter. One is they given the different parameter, that is pass band frequency, stop band frequency, pass band attenuation, stop band attenuation, and from these parameter by using n you can find out the number of filters. So from that number of filter, once you find out the value of number of filter, then as per the value of filter, as per this coefficient of the filter, we are going to find out the value of h of s. How you find out the value of h of s? So h of s is find out that values depending upon the table. So how you got that table? So I think these are the problems we will discuss. We have a discussion on these already. So we get the n is equal to 4. And then once you get the n is equal to 4, we end up our discussion here. But when we are converting, when we have a designing of filter by using this different method, so after that there is one step to design. So n is equal to 4. So how you are going to use that n is equal to 4? So these are the different diagrams for understanding. So just see the diagrams. Ideal frequency response for Butterworth filter. So these are the different response for value of order of filter. So first order, second order, third order, these are the order of filters. And this black line shows the ideal response of the filter. So these are the different diagram for understanding of the filters only. So I'm going to clear that drawing so that. So this is one problem statement. Determine order and poles of low pass Butterworth filter has a 3 dB attenuation at 500 hertz and an attenuation of 40 dB at 100 hertz. So low pass filter means this frequency is going to pass. So from the diagram we analyze that these are the different data from the given statement. So alpha p is 3 dB, alpha s is 40 dB, alpha p is, so it is given in radian per second. So we are going to find out the values in radian per second. It is given in the hertz. So how you are going to convert into radian per second? Multiply this whole factor to 2 pi into 500. So it is 100 pi radian per second, and passband frequency is 2 into pi into 100. So it is 200 pi radian per second. So now substitute the value in this formula, then we get the value 6.6. So when we substitute 6.6, so it is ultimately n is equal to 7. So this 7 is the value of order of filter. Now this is one example. This is one thing which is given in a problem statement. When we get n is equal to 1, our task is to find out the value of h of s. So h of s is given for the normalization of the filter, that is cutoff frequency is equal to 1 radian per second. So s of k is equal to cutoff frequency e raised to j phi k. So j phi k is this equation and k is the value of 1, 2, 3 up to 7. So phi of k is pi by 2 plus 2k minus 1 into pi divided by 2n. So this is one formula, and by using this formula you can find out the different values of the equation. So this is one example. I think we have a discussion on this. This is the formula for calculating the cutoff frequency using passband frequency and stop band frequency. So this is the formula for cutoff frequency by using the passband frequency, and this is the formula to calculate the cutoff frequency by using the stop band frequency. So this may be one of the formula for your understanding, and you can use this formula for solving the problem statements. So this is again one of the example which we have already discussion design analog Butterworth filter that has a minus 2 dB passband at attenuation at a frequency 20 radian per second and minus 10 dB stop band attenuation at 30 radian per second. So what is the value of passband and what is the value of stop band? It is given. So passband is 2 dB. Passband frequency is 20 radian per second. Stop band frequency is 30 radian per second. So this is the equation. By using this, you can find out the value of n. So you get the value of n 3.34. That is higher side get converted into h of s. Now this is one part of the problem statement. Now in the second part of the problem statement, what happened? Once you reach to this point, that means the very first point is from the parameter you find out the value of n. So once you get the value of n, from that there is one table. The table is given, and that table, how this table is formed, this is the main question. It is not the thing that ready-made table is given. Table is created by using the different value of n. So we have, that means we will discuss all these things in the coming lecture, how this table is coming, how where this you get the value of this h of s. So when n is equal to 4, so that value is came h of s is equal to 1 by s square 0.76537 s plus 1, and s square is equal to 1.8477 s plus 1. So these are the values of h of s. So h of s is equal to this value you get from the table. So that table we have the I'm going to see that table here. So just wait for 2 minutes. I'm showing that table to you people so that you understand the discussion. This is the table. So one, it is either 1 plus s or it is the simple table I have. So s plus 1, s plus 2, that table also we have. You refer these tables. So first, when the value of n is equal to 1, so s plus 1 is came. So how this s plus 1 is available here? So try to just see the discussion. Now this is the formula, that is I'm writing this formula at the right side so that it is visible to all. So h of j omega is equal to 1 by 1 plus analog frequency divided by analog cutoff frequency square raised to n. So this is one formula, we have that formula, and here we are trying to find out the value roots of this equation. So when we want to find out the roots of this equation, s is equal to, so substitute s is equal to j omega here. So when I am making the square of both the side, so when I'm s, what is the value of s? S is equal to j, that is imaginary term and analog frequency, taking the square of both the sides. So j square analog frequency square s square. What is the value of j square? It is nothing but the minus 1. So frequency is equal to minus s square. So this j square is representing a minus 1 term. So I'm going to substitute this lambda is equal to minus of s square in this equation. So here this value I'm going to substitute in this equation. This is one equation. So when we substitute the value of lambda square is equal to this, so the equation become h of s, h of minus s, splitting the value of this equation now is equal to 1 by, when I'm substituting value, this lambda square is equal to, so the value I'm substituting 1 plus minus s square divided by cutoff frequency raised to n. So this value is came when we substitute the s is equal to j omega and we get this value. Now we want to find out the poles. So poles of h of s can obtained by finding the roots of denominator. So when we want to find out the roots of denominator, equate this denominator to the 0. So when I am equating this denominator to the 0, so what happened? 1 plus in bracket s square divided by cutoff frequency raised to n is equal to 0. When I am substituting this value, so when I am shifting this equation to this side, so it is y minus 1. So s square divided by cutoff frequency square is equal to minus 1 raised to 2n. There is no what you say that extra mathematics we taken a reference, only it is a simpling and only shifting this one to this side and this equation is become this. Now I'm shifting, I want to shift this 1 of n. So when I'm shifting to 1 of n this side, so it is 1 by n. So when it is 1 by n, minus 1 raised to 1 by n. So what is the value of this minus 1? So when I'm substituting the value of minus 1, see this is one equation. So we reach to this equation. Now let us consider e raised to j 2k plus 1 into pi. So this is one equation. E raised to minus j 2k plus 1 into pi. So this equation is visible to all. This equation is visible to all. I need a response. This equation is visible to all. E raised to e raised to j. It is not minus j. E raised to j. This equation is visible. When I use this equation, substitute the value of k here. So when I am substituting value of k is equal to 1. So what happened? When I am substituting the value of k is equal to 1, so the equation is, so when I am expanding this equation, so it is cos of 2k plus 1. So this equation we got. So e raised to 2k plus 1. So expansion of this equation is here. So when we expand it, it is cos of 2 pi, cos of 2k plus 1. When I substituting k is equal to 1, so value is pi, 2 pi, 3 pi, 8 pi. When we calculate the value of cos, so it is always the minus 1. So instead of this minus 1, which is we find out this minus 1 raised to 1 by n, so we can substitute this value. So e raised to j 2k plus 1 into pi raised to 1 by n, and this is the value of minus 1. When we substitute this value instead of minus 1, so the equation become, so the screen is visible to all. I need a response. Screen is visible to all. Screen is visible. So when we substitute e raised to j 2k plus 1 into pi, and then we are going to solve this example for e raised to. So the next step is, see, we are going to multiply that pi to the pi n. So e raised to j 2k plus 1 into pi by n. Then what happened? Shift this cutoff frequency, to this side. So this minus become a, this here side minus of cutoff frequency into e raised to this. So s square is equal to this. Now the coefficient is minus 1, so it is the minus 1 square of cutoff frequency is equal to this. Now we take the square root of both the side. When we take the square root of both the side, what happened? This minus 1 is minus root, under root. So it is under root minus 1 cutoff frequency, and this is pi by, it is 1 by 2. So under root 1 by 2. So what is under root 1 by 2? It is j. So it is nothing but j. So pk is equal to plus minus j cutoff frequency e raised to 2k pi by n raised to 1 by 2. So it is either 1 by 2, or you can multiply this by pi by 2n. So this is one equation. Now considered the separation of these equations. So when we separate it, so it become e raised to j pi by 2 cos of pi by 2 plus sin of pi by 2. So what is the equation here? Cos of pi by 2 is 0, minus j, it is the j. So shall I substitute instead of this j, shall I substitute e raised to j pi? So when I substitute e raised to j pi instead of this imaginary values, so the equation become this. So pk, that is poles of the equation, is plus minus cutoff frequency e raised to pi by 2 into e raised to 2k plus pi to pi n. So when I take the common of imaginary, so it is the pk is equal to plus 1 by 2 e raised to j pi by 2, and it is in the bracket. And for normalized filter, it is pk is equal to j pi by 2, and this is the, we get this is equation. Now after that, what happened? When I substitute n is equal to 1 in this equation, so what happened? So when I substitute, see when I substitute E, so this is one part of the discussion. This is second part of the discussion. I hope screen is visible to all. See, this is the system function n is equal to 1. When n is equal to 1, k is equal to 0. So it is n 1 by 1. So when I substitute k is equal to 0, pk is equal to p0 e raised to minus j pi by 2, 2k. So 2k it is 0. So it is the e raised to, that is this term is 0. So it is only pi by 2n. So it is pi by 2 and it is pi by 2. So when it is pi by 2 and pi by 2, it is e raised to j pi. So it is plus 1 and minus 1. So that's why the equation, that's why the poles of the equation is for n is equal to 1, what is the pole? So it is h of s is equal to 1 by s plus 1. So when we take s is equal to k is equal to 1, the pole of the equation is minus 1. So it is in the left hand side of the half plane. So it is s is equal to minus 1. So it is equal to 1 by s. So that's why in the table it is given for value of n. So the expression is s plus 1. So that expression I am showing to you, but it is for n is equal to 1. Similarly, we can find out for n is equal to 2. So what is n is equal to 2? So when I substitute n is equal to, so what is the value of k? The first value of k is n by 2. It is two values, 0 and 1. So when I substitute the first value, so we get the value s plus 1. And for second value, that is k is equal to 1 and k is equal to 2. K is equal to 0, n is equal to 2. K is equal to 1, n is equal to 2. So here when we substitute these values, e raised to j pi by 2, 2k plus 1 divided by 2n into pi. When we substitute the value k is equal to 1, k is equal to n is equal to 2. So we get these poles, minus of 0.070 minus of j 0.07, and these are the two poles we got when we substitute the value n is equal to 2. Now so depending upon n is equal to 2, n is equal to 3, these are the tables we got. When we substitute similarly 3, you got this equation. When we substitute n is equal to 4, so you got these expressions. So this is a standard table for designing a filter. That's why when we got n is equal to 4, directly we taken these value of h of s. So 1 by this value. Once you get this value, this is for normalized filter. So what is mean by normalization of the filter? Normalization of filter is nothing but cutoff frequency is equal to 1 radian per second. It is called as a normalization of the filter. And when we want to find out the value for the particular type of filter, so we are going to substitute s is equal to cutoff frequency in that equation, and you get the value of that equation. So this is one part of the discussion. Now we are going to find out the expression. Now examples of how you are going to design a filter by using the different methods. So this is for n is equal to s plus 1. For n is equal to 2, s square plus 1.414 s plus 1. You can write like this also. So in some of the book it is given like this, but in some of the book it is given like this. S is equal to, you can write for this same equation s plus 1. You can write this equation is s square plus 1.414 s plus 1. This is for n is equal to 3. So n is equal to 3 is s plus 1. And second one is s square plus s plus 1. So this is for n is equal to 3. Now what is n is equal to 4? So n is equal to 4 is this. So s square plus 0.765s plus 1 and s square plus 1.48s plus 1. So these are the different value when we find out the for coefficient of the filter 1 to 4. This is the table up to 10. So this is the value of h of s. So see, so h of s for normalization of the filter. What is mean by normalization of the filter? Cutoff frequency is equal to 1 radian per second. So this is the complete discussion. This is again the repeat. It is not visible. That's why I put this repeated notes to you for you people. So the same thing here we have the discussion how to find out the value. Now we are trying to find out the different examples. So we have an example. So this is one example. Design an analog filter for minus 2 dB passband frequency and minus 2 dB passband attenuation at a frequency 20 radian per second. So from the given problem statement, you can extract the information of alpha S, alpha P, ohm S and ohm P. So what is alpha S? Alpha S is your passband frequency 2 dB, passband, this is passband attenuation, this is passband frequency, stop band attenuation, stop band frequency. By using this formula, n is equal to log of 10 raised to 0.1 alpha s minus 1, we can substitute the value. Once you substitute the values, so the equation become log of 10 raised to 0.1 into minus 1. So this is the equation. Now you get the value of 3.37 here. Now n is equal to 4. So from the table you can directly take this h of s is equal to s square 0.765 s plus 1, s square plus 1.877 s plus 1. So once you get n is equal to 4, directly you can take this equation for normalization of the filter. So once you get this h of s, now the next task is to find out the cutoff frequency. So how you are going to find out the cutoff frequency here? So see, cutoff frequency is equal to passband frequency 10 raised to 0.1 alpha p minus 1 into raised to 1 by 2n. So what is the passband frequency which is given? So passband frequency is 20 radian per second, 10 raised to. So cutoff frequency, the value of cutoff frequency is 21.3. Now, what is the next step? Substitute the value of S is equal to S by cutoff frequency. So you get the values of H of S for the particular type of the filter. You get this value only for the cutoff frequency. So normalized filter. But we are not interested to calculate the normalized filter. We are interested to calculate the filter for this type of specifications. So now, once you know this S is equal to 21 by 38, so I can substitute these values here. S is equal to S by. So when we substitute the values here, so this equation becomes substitute S is equal to S by 21 by 30, 3868 and rewrite this whole equation. When we rewrite this equation and solve it, so this is your H of S and this is nothing but the designing of analog filter for the given parameters. Now this is the final equation we expected to write in exam. After that, someone asks you to calculate the h of z by using the bilinear transformation. Just change this value s square. S square is equal to 1 minus z divided by 1 plus z, substitute the value and rewrite this equation, you get the value of h of z. That means when you want to design a filter in digital domain, so our role is to find out the value of order of filter and find out the h of s. Once you got the h of s, immediately find out the cutoff frequency. Rewrite this whole equation after substituting the value of s is equal to cutoff frequency, and whatever the equation we got, this is the final equation for h of s. Then after that, in suppose in the problem statement it is mentioned that you need to find out the equation by using the bilinear transformation, approximation of derivative, or the impulse in variation method. So according to the formula of s, you can find out the value of h of z. So this is one problem statement. Now this is one problem statement which is very important. For a given specification, design an analog filter. So this is the specification is given. It is not given the passband frequency, stopband frequency, passband attenuation and stopband attenuation. So this is one of the way that the people is giving the problem statement, and our task is to extract the information for the given statement. So our task is to design analog filters. So what are the parameters to design analog filters? What we need? So write down the basic formula. What is the basic formula? Anyone can tell me what is the formula of n? I need answer. What is the formula of n? Anyone can tell me what is the formula of n? My voice is clear to all? Screen is visible?
Yes, sir.
Anyone can tell me the formula of n? What is the formula of n? Log of, tell me the formula, log of under root divided by log of stop band frequency divided by pass band frequency. Here 10 raised to 0.1 alpha s minus 1 divided by 10 raised to 0.1 alpha p minus 1. So where this is pass band attenuation, stop band attenuation, this is stop band attenuation, pass band attenuation, stop band frequency, pass band frequency. Now our role is to find out these parameters, but here this parameter is not given directly, this is given indirectly. So for this you need to understand the diagram. So this is one diagram which is given here. So see, this is the diagram which is very important for everyone. 0.9 it is given, 0.9 it is 1. So in problem statement this 0.9 is less than h of j of omega is less than 1. So ideal diagram is 1. Now here below that it is given 0.9. So this 0.9 and 0.2, here it is 0.9, it is representing for the value 0.2 pi. So 0.9 is the value representing for the 0.2 pi. So it is mentioned here in the diagram, or it is when we are drawing the diagram here. So see, this is the expectation that everyone need to understand these equations. So when we given 0.9, so 0.9 is 0.2 pi. This is pass band. Now 0.2 is given for the interval, or for the s is equal to 0.4. So it is a passband frequency, it is a stop band frequency. For stop band frequency, it is 0.2 is given. So, and in the standard diagram, this is 1 by epsilon square. This 0.9 is equal to 1 by under root. So it is 1 by under root 1 plus lambda square. And this value is equal to 1 by under root 1 plus lambda square. So this value is equal to 0.2, this value is equal to 0.9. When we substitute this value in the equation, so this is the value of what you say that it is lambda by epsilon. This is the value of lambda by epsilon. So this is one of the, what you say, that instead of giving this 0.5 of alpha, 0.5 of L, so it is directly given the alpha and lambda value. So we have the formula. This is one of the formula for finding the value of n. So what is that formula? It is given. So in the last discussion, I told you that this is one of the formula. You can write this formula also. N is equal to lambda divided by epsilon. So directly it is given. So it is 3.34. So once it is, what is the value of 3.34? It is value of coefficient of filter, that is capital N. So it is get converted into the higher value of n. So you get n is equal to 4. So when n is equal to 4, so from the table you take the values. Now our intention is to find out the cutoff frequency. Here passband is given or stop band is also given. So by using the stop band and passband, this is the formula to calculate the cutoff frequency. So what is the cutoff frequency here? 0.2 pi cutoff frequency. So substitute this value in this equation and rewrite this whole equation. When we rewrite this whole equation, then you get this value. And this is nothing but the designing of analog filter for the given specification. So the solution, that is solution of this problem statement is, for the given specification, design an analog Butterworth filter for this interval. So you can try to extract the information given in the problem statement. This is one major task which we observed during the solving of problem. So this is the very first lecture. To maintain the link between last lecture and this lecture, I hope everyone understanding the things at home. You will have the practice discussions, and during the practice